Okay, now we've got through those first few examples, and we're now on to more than likely what they would ask you in an exam. And this is where something is projected at an angle. So there's no reason why they couldn't ask the earlier examples, but more likely it's going to be something like this. So something is going off at an angle, and there's so much more they can test really in this. So in this, you imagine u is your speed at which something is being projected, and it's being projected at an angle of theta to the horizontal. So what we said earlier on still applies. So that was that the horizontal speed is going to be the same. So horizontal velocity all the way through is going to be the same. So the horizontal velocity isn't just going to be u, it's going to be u, and then you've got, so horizontally it's u cos theta, and that will be the same throughout. So your speed horizontally will be u cos theta throughout in these questions. Okay. Vertically, but it's a different story. So vertically, just a wee dash line vertically up here, my initial vertical speed would be u sine theta. So go back to resolving forces videos and notes and look at that. If you're resolving vertically, here in this case, we don't have this angle in here. If you don't have the angle, you use sine. So it is u sine theta. That is just my initial vertical velocity. That will change. So at some points, a point along the line here, we'll look at a couple of key points. At this point, for example, at the highest point, at your highest point, your vertical velocity will be 0. So at your highest point, vertical velocity will be 0. And back here, your vertical velocity at this point, it's the same level as this. So it will be exactly the same as this, except it will be going downwards. So it will actually be vertically going upwards. It will be minus u sine theta at that point. So just to run through that again, horizontally, your speed horizontally is always going to be u cos theta, and this up here is just your initial vertical speed is going to be u sine theta, and that will change throughout the motion. Okay, we're going to look at a couple examples on these, and we'll talk through all the different things in the course of these examples. This example says a particle is projected from a point on a horizontal plane and an initial velocity of 28√3 meters per second at an angle of elevation of 60 degrees. Find the greatest height reached by the particle and the time taken to reach this point. So let's just do a diagram of what's going on at the very start. I've marked on my horizontal line, and it was 60 degrees, and it was my initial velocity was 28√3 meters per second. Okay, all I need to do is work vertically here. It doesn't. It's talking about the greatest height, so it's vertical is all I'm really concerning about. Just mark on a wee dash line vertically up here, just to help us out. So we'll just say vertically, and what we have is our initial velocity u is equal to 28√3 times sine of 60. And so if you do that, you work that out, that means your u is equal to, just do that on your calculator, 28√3 times sine of 60. And I've done that on my calculator, and it gives me a very nice answer of 42. Again, they've engineered this question, so it's a nice, we're working with nice numbers. So it's 42, upwards, 42, I should have said 42 meters per second upwards. That's fine. My acceleration is going downwards, so it's minus 9.8 meters per second squared upwards. My v is equal to 0, put in brackets, just say because that's at maximum height. So at maximum height, instantaneously, your vertical speed is 0. And that is it. And what you want to find is to find the greatest height. So that's what we're trying to do here, to find this s. So to find this, we're going to use b squared equals u squared plus 2as. So we're going to just rearrange it. We're just going to sub in. I think we prefer to sub in just that's going to be 0 is equal to 42 squared plus 2 times a minus 9.8 times your s. And a wee bit of working out over here to see what we're going to get for this. That's going to be 19.6 s is equal to 42 squared, whatever that is. S works out to be 42 squared divided by 19.6. And let's just check that. 42 squared divided by 19.6. So my S works out nicely to be 90 meters. So we found the greatest height. Last part says find the time taken to reach this point. So I'm just going to say V is equal to U plus AT. So my 0 is equal to my initial speed of 42 plus my acceleration, which is minus 9.8. So I'll write minus 9.8 t. So that's going to be 9.8 t is equal to 42. So t works out to be 42 divided by 9.8. And then let's just do that in your calculator. 42 divided by 9.8. And I have got, I'm just going to leave it as a mixed number, 4 and 2/7. And that's going to be time. So that's going to be seconds. And that is it. Next example says a particle is projected from a point on a horizontal plane and has an initial velocity of 45 meters per second at an angle of elevation tan -1 of 3/4. Find the time of flight and the range of the particle on the horizontal plane. So first thing we need to do is sort this thing out. So this is the angle of elevation, which is a bit weird. So that means that tan theta is equal to 3/4. So let's just draw a wee diagram. There's your theta. Tan is equal to opposite over adjacent, so 3/4. And then by Pythagoras, or by knowing your Pythagorean triples, you'll know that that's going to be a 5. Which tells you, very handily, it tells you then sine theta is equal to 3/5. And cos theta is equal to 4/5. Once you've got those, folks, it's going to make life so much easier. We're going to look vertically and we're going to look horizontally, just as we did before. So find the time of flight and the range of the particle on the horizontal plane. We're going to need both of those things. So let's go vertically. So my initial velocity, U, my initial velocity is 45 sine theta, which is going to be 45 times 3/5. And if you work that out, you're going to get just 27 meters per second vertically. So this is us doing our time of flight. So you imagine if this thing starts at a speed, a velocity I should say, of 27 meters per second upwards, it's going to finish with a speed of 27 meters per second downwards. So minus 27 meters per second upwards, basically. And your acceleration is always going to be minus 9.8 meters per second upwards. And what we want to find, first of all, is our time. So we'll find our time of our flight. So we're just going to be using V is equal to U plus AT. So in this case, it's going to be minus 27 is equal to 27 minus 9.8 t. And if we work that out, that's going to be minus 54. And divided by minus 9.8 is equal to your t. And let's just see what that works out to be. And I have got 5 and 25/49 seconds. Horizontally then, we now know our time. That's our total time for a flight. Horizontally, it's just going to be to find the range. The range is just how far the thing has gone. So it is just going to be S is equal to your initial speed. Distance equals speed times time, I should say. Distance equals speed times time. So in this case, the distance is equal to my speed. My initial speed is going to be 45 cos theta. And that's going to be my horizontal speed throughout. my time is now 5 and 25 over 49. So that is just going to be 45 cos theta in this case is going to be 36. So 36 times 5 and 25 over 49, which works out to be 198 and 18 over 49 meters. So just tidy that all up and just say my answer. My answer is going to be my time was 5 and 25 over 49 seconds, and my distance is equal to 198 and 18 over 49 meters. So if you give those to 2 decimal places, you could, or 1 decimal place, sorry, you could say your time is 5.5 seconds, and that's to 1 dp, and your distance is 198.4 meters, and that's to 1 dp. Okay, this example says a particle is projected from an origin O with a velocity of 30I plus 40J meters per second. Find the position and velocity vectors of the particle 5 seconds later. Hence find the distance of the particle from O and the speed and direction of its motion at this time. And it says take G is equal to 10, so hopefully I've done that. Okay. It moves initially with a velocity. So it moves with a velocity of 40J going upwards and 30J going 30I going to the right. So that's your initial velocity. I should have meters per second on those. So that's what we've got going on at the start. So let's again look at the vertical. If you're looking at your vertical, your U is equal to 40 upwards, your A is equal to minus 10 upwards, and it says after 5 seconds, so T is equal to 5. So we will find our V first of all. So V is equal to, that's what we're looking for here, so V is equal to U plus AT. And if you put all of that in, you're just going to get 40 minus 10 times the 5. So it works out to be minus 10, which is the same as minus 10J. Also, here we could look at our displacement. So U again is equal to 40 upwards, your A is equal to minus 10 upwards, your T is equal to 5. We're trying to find S, so we're going to say S is equal to UT plus a half AT squared. So in this case, S works out to be 40 upon 5 plus a half times my A, which is minus 10, times my 5 squared. So your S works out to be 75 meters. Okay, so 75 meters, i.e. that is S is equal to 75J. So we've now found the vertical component of the velocity, and we've now found the vertical component of the displacement. We now have to look horizontally and see what we get. So your S is equal to just going to be 30 times 5, so it's going to be 150, which is going to be 150 I meters. And your V horizontally is dead easy. It's the same throughout, so it's just going to be 30 I meters per second. So now we've got what we've got to do. We've got to do this twice. Don't know why we've got to do this twice. A bit of overkill really in this question. But we'll look at the displacement first of all. So for your displacement, or for the distance, I should say, it's to find the distance of the particle. So it is now going to be, it goes 150 I across, So that's 150i. And then it goes 75 vertically. So 75j. And what we need to find is our S in here and the angle as well. Hence find its distance of the particle and its direction. Well, we'll not find the angle just yet, but we can do that later on. Sorry, I'll do that when we're doing our velocity one, apologies. We'll just find the S. So S just equals the square root of 150 squared plus the 75 squared. So S works out to be, do that in your calculator, 167.7 meters, and that's to 1 dp. Okay, for the last bit, we're going to do the speed. So the speed, it was 30 to the right, that was 30i, and it was 10j going downwards, so it goes down 10j, so it was minus 10j, and what we want to find is our v, which is just Pythagoras, and we use trig to find this. So your v works out to be 10 squared plus 30 squared, square root of all that, so your v works out to be 31.6 meters per second, and that's to 1 dp. And your tan theta is 10 over 30, which means shift and tan, or tan to the minus 1 of 10 over 30, and I got 18.4 degrees to 1 dp, and that is, very importantly state that, that is below the horizontal. Okay, so you've worked out your distance was 167.7 meters, and your velocity is 31.6 meters per second, and yeah, it was acting at 18.4 degrees below the horizontal. Next example says a stone is thrown from the edge of a vertical cliff with a velocity of 50 meters per second at an angle of tan to the minus 1 of 7 over 24 above the horizontal. The stone strikes the sea at a point 240 meters from the foot of the cliff. Find the time for which the stone is in the air and the height of the cliff. Okay, right, first thing we're going to look at is this, tan to the minus 1 of 7 over 24. So what that means, there you've got your angle, theta. Tan, remember, is equal to, tan is equal to opposite over adjacent, so that's 7 over 24. And by Pythagoras, you can work out that this is 25. So this is a lovely one they've used. They've used a nice Pythagorean triple, 7, 24, 25. So that means, so where I got that from, remember, was tan. They told us tan to the minus 1 of 7 over 24 was the angle. So that means tan theta is equal to 7 over 24. We then could calculate this 25. And then from that, we can get that tan theta, sine theta I should say, is 7 over 25. And cos theta is equal to 24 over 25, which will be really useful for us in the rest of this question. Okay, in this one, we're going to look first of all at the horizontal motion. So in the horizontal motion, we know the speed is constant, so it's distant. So distance is equal to speed times time. And we know the distance that it travels is 240 meters. The speed is going to be u cos theta, which is going to be 50 cos theta, and then that's times your time. We'll call that t just. So that means 240 divided by 50 cos theta, which remember was 24. That's a 24, believe it or not. 24 over 25 will be equal to your t. So t works out to be 5 seconds. Okay, so that means it is in flight for 5 seconds. So we'll just write that. So in flight for 5 seconds. Okay, the next thing we're going to look at obviously is going to be your vertical motion. So we look at the vertical motion. Your u, your initial velocity, is 50 sine theta. So in that case, that's going to be 50 times 7 over 25, which works out to be just 14, and that's going to just say meters per second, and that of course is upwards. Your acceleration is against that because it's gravity is working downwards, so it's minus 9.8 meters per second squared upwards. Your time is equal to 5. And what we want to find in this question is your displacement. So the stone is in the air, structure, find the time for which the stone is in the air and the height of the cliff. So we've got the time, we're now trying to find the height of the cliff. So we're going to use S is equal to ut plus a half at squared, and then just fire everything in that you know. 14 was my u, my t was 5, a half times my a, which is minus 9.8, times my 5 squared. Work that out and see what you get for your s, and I have got minus 52.5 meters. Okay, so that means basically relative to where you start, this thing has started, it's been fired, and it ends up 52 meters down. So that means the height of the cliff is 52.5 meters, and that is it. Okay, so just say, finish it off, just say, therefore, height of the cliff is 52.5 meters. This example, it says, a shell fired from a gun has a horizontal range of 960 meters and a time of flight of 12 seconds. Find the magnitude and direction of the velocity of projection, and take G in this case to be 10 meters per second. So always check things like that. They may cycle between 10 and 9.8. Okay, so we're going to look horizontally. Horizontal first of all, and remember speed is constant horizontally, so distance is just equal to speed times time, and the range is 960, so that's the distance it's gone, and the speed we don't know, that's what we're trying to find. Where we'll just say speed times time, so we'll just say our time is 12 and we'll call our speed v. So a wee bit of working out then, 960 divided by 12 is equal to your v, so v is equal to 80 meters per second. Now we're going to look at the vertical motion. So for the vertical motion, our u, we're just going to let it be equal to u upwards. My v, when it comes back to the ground, basically back to where it started, it's going to be minus u. It's going to be the same speed but in the opposite direction. So it's minus u. My a is equal to minus 10 upwards, and my time is equal to 12 seconds. So the formula we're going to use is v is equal to u plus at. And then just put everything in. Minus u is equal to u, and then that's going to be plus minus 10 times the 12. So a wee bit of working out, that's going to be 120, bring that across, is equal to 2u. So u works out to be just 60 meters per second. Okay. So initially, so this is way back at the start, what we now know, it had this sort of setup. It was 60 meters, it had a vertical speed component of 60 meters per second, a horizontal speed component of 80 meters per second, so that's what it looks like. All we're going to do is redraw this and make this into a right angle triangle using your sort of nose to tail method. So we'll do 80 horizontally, and then we'll go 60 vertically, and our overall velocity, we're going to call it v. And we'll have theta here because we need to find our v and our angle theta. So we'll do our v down at the bottom, squeeze it in. V is going to be equal to, it's just Pythagoras, put a wee right angle triangle, right angle in there. 80 squared plus 60 squared, square root of all that, see what you get, and that's a lovely one. That works out to be 100 meters per second. And then your tan theta, tan remember is equal to opposite over adjacent, so it's going to be 60 over 80. And then a wee bit of working out, your theta works out to be 36.9 degrees, and that is to 1 decimal place. This example says a ball is projected with a velocity of 28 meters per second. If the range of the ball on the horizontal plane is 64 meters, find the two possible angles of projection. Okay, let's just do a sketch to start with of our angle of projection. It's projected at 28 meters per second. And there is theta. That's all we know at the very start of this question. So we're going to look vertically. Vertically first. Okay, I've sort of been cycling between vertical and horizontal first. It doesn't really matter. If you find out you haven't got enough information from whatever one you do first, then you obviously have to just go back to it. That's all that will happen. So vertically, my initial speed is going to be 28 sine theta, and that's upwards. And when you come back to land, hits the ground again, it's going to be minus 28. Your velocity is going to be minus 28 sine theta upwards. Your acceleration, they haven't told us, so we have to assume it's minus 9.8 upwards. And your t, we're going to say, is equal to t. So if we just say then, that means v is equal to u plus at. So in this case, that's minus 28 sine theta is equal to 28 sine theta, and then that's going to be minus 9.8 t. So a wee bit of working out here again. You're going to have 9.8 t is equal to 56 sine theta, and we will get from this that t is equal to, and it's going to be, if you do 56 divided by 9.8, do that in your calculator, it'll come out as 40 over 7 sine theta dot dot dot. And you can see here we haven't come out with like t is equal to something or anything like that. We've got an equation here, or equation 1 as I label it, has got two unknowns in it, so we'll have to revisit this later on. Okay, we're going to look now at our horizontal motion. So horizontally, and see what we have. Again, speed is constant horizontally, so it's just distance is equal to speed times time. So in this case, it's going to be 64 was your range, so 64 is your distance. Your speed is going to be 28 cos theta, and your time we don't know, so it's going to be t. So that means in this case, t is going to be equal to 64 divided by 28 cos theta, and if you do that, 64 over 28, it cancels out to be 16 over 7. But the cos theta, remember, is on the bottom line as well. And we'll call this 2. Okay, they might not be nice, your equation 1 and your equation 2, but you've got two equations and you've got two equations and two unknowns. You can see them now. Two equations, two unknowns, so you have enough mathematics in you to solve it. So have a wee bit of confidence in yourself. So the easy way to do it here is you can see t is equal to something in equation 1, t is equal to something else in equation 2. So we're just going to put equation 1 equal to equation 2 and see what happens. So in equation 1, equation 1 equal to equation 2, I'm going to say then that means 40 over 7, the sine theta I should say is on the top line of this one, so it's 40 sine theta over 7, it's a wee bit messy, is equal to 16 over 7 cos theta. And then what we can do is just multiply across, and if you multiply across, I'll do a few steps to this. This is going to be 40 sine theta cos theta is equal to 16. So notice what I've done here is I've just multiplied across by the cos theta. Effectively what I've done here is I've cancelled out the 7s, both the 7s on the bottom line. Okay, so what we get, that means you can cancel it, divide across by the 16, divide across by the 40 I should say. You'll have sine theta cos theta is equal to 16 divided by 40 is just going to be 2 over 5, and then that's just going to become that what I could do is multiply both sides by 2, so I'll have 2 sine theta cos theta is equal to 4 over 5, and 2 sine theta cos theta, 2 sine theta cos theta is the same as sine 2 theta is equal to 4 over 5. And then we're into our basic angle territory. So BA, basic angle, just check that out in your calculator. Sine to the minus 1 of 4 divided by 5. Press equals. I have got 53.1, and then we're into our CAS diagram. So C, A, S, and T. Sine is positive, so it's going to be in here, 53.1, or in here. So that means my two angles, 2 theta is equal to 53.1 degrees, or 180 minus 53.1 is going to be 126.9 degrees. So my final answer then, divide both of those by 2, you will get 26.6 degrees to 1 dp and 63.5 degrees, and they're both, squeeze that in, both to 1 dp. Okay, this is our last example for this video. It says a golfer hits a ball with a velocity of 52 meters per second at an angle alpha above the horizontal, where tan alpha is equal to 5 over 12. Set up a mathematical model of the situation to determine the time for which the ball is at least 50 meters above the ground. And in this case it says take g is equal to 10 meters per second squared. So we've done the first bit of this for you. We've told you the mathematical modeling bit. So this is a common addition to these questions. These are questions that I don't really like, to be honest, but you're better off just learning off what these assumptions are. So anytime these are in your notes, just learn them off so that you can just regurgitate them in an exam. So the modeling assumptions are as follows. So consider the golf ball as a particle. So that means its size is negligible. So it's so small that it doesn't really matter what size. So you're considering the golf ball as a particle. In reality, the golf ball would. The size of it and shape of it would matter, and if you are a golfer, you'll know maybe about people putting backspin on the ball and so on, all these sorts of things, but we're considering that is not important at all. And we're assuming that any air resistance is negligible. And why we have to do that is, remember, we're always considering in these questions that the horizontal speed is constant. If there was air resistance, that would not be the case. It would slow down horizontally as it moved along. And we're also going to assume the ground to be level. And we're assuming that nothing impedes the motion of the ball, so it doesn't hit a tree or doesn't hit a spectator or anything like that. So nothing impedes the motion of the ball horizontally or vertically, and that's it. Okay, we're just going to do a very simple diagram of the start of the setup of this question. So it moved at a velocity of 52 meters per second, and it moved at an angle of alpha to the horizontal. And remember, it said that tan alpha is equal to 5 over 12, which means, let's just do a diagram of that, what that actually means. There's your alpha. Tan, remember, is opposite over adjacent, so that's 5 over 12, and that is 13 in here. So sine of alpha is equal to 5 over 13, and cos of alpha is equal to 12 over 13. So we've done a good bit of this already. We're in a good place now. We've got our sine alpha and our cos alpha. We'll need this for the rest of the question. Okay, we're going to look, and it says in the question, what we're to do is set a mathematical model for the situation and determine the time for which the ball is at least 15 meters above the ground. So we're only really considering the vertical at this stage. So for the vertical, your u is equal to 52 sine alpha upwards, which means that if you do that, 52 times 5 over 13, you're going to get just 20 meters per second upwards. Your acceleration is minus 10 upwards, and we want to find out when it is at least, it says at least 15 meters upwards. So that's what we're looking for. And we're looking for the time at which this occurs. So to do that, we're going to quite simply use S is equal to ut plus a half at squared. So if you do that, you put that in, that's going to be 15 is equal to 20t. minus a half times minus 10, which is going to be minus 5t squared. We'll bring that all to the one side to make it all equal to 0. So 5t squared minus 20t plus 15 is equal to 0. We can divide through by 5 to make life a wee bit easier. So t squared minus 4t plus 3 is equal to 0, which means t minus 1, t minus 3 is equal to 0, which means t is equal to 1 or t is equal to 3. Okay, what is actually going on here? Now, my diagram here is not going to be great. There's my ground, and this thing goes up and it goes down, but at a couple of times it is going to be at, that's 15 meters, we're going to say that's 15 meters high, and at first time it is at 50 meters, a height of 50 meters is t is equal to 1. The second time is at t is equal to 3. So that's really what is going off. It's been blasted up this way, and then at a certain time it's at 1 second it's 15 meters high, and then it goes up beyond that, and then at 3 seconds it's 15 meters high. So the question says, determine the time for which the ball is at least 50 meters above the ground. So you need to do this last bit. Your answer, the time for which it's 15 meters above the ground, is 3 seconds minus a 1 second, which is 2 seconds. And that is us done. Okay folks, that's the end of that video on angular projection, projectiles and angular projection. So you've now done horizontal projection and angular projection.